Hello again. Sorry, somehow I managed to push the stop record button without realizing it. So that's the reason for the two parts. Okay, where we left off in the last video was number 10 in Desmos. I explained how to come up with a number line. And they're asking at -4. So -4, I put in the table, but it is undefined. That's okay. We don't need it to be defined at 4. What we're asking is, as we approach -4 from the left, is it the same value as we approach on the right? We cannot tell from the graph what's happening because it's -4 would be right here, and we actually can't see. So -4 on the left looks like -20,000, right? That's this. And then, but on the right, it's +20,000. Those do not agree. The limit does not exist for number 10. Let's go on to number 11. Number 11 is a piecewise function. I made a table. And for those of you that are still struggling with making a table, what values to input? Put 3 right in the middle. Go one number over on each side. And then go 1/10 away. So let me make this a little bit bigger. 3, it only gets bigger on my side to make it clearer to write. So let's, oops, that wouldn't be 3.1. That doesn't make any sense. That would be 2.9. And on the other side, 1/10 away would be 3.1. Okay, I'm not drawing it to scale. I'm helping you to understand what's between 2.9 and 2.3. The way you get closer is you add a 9. And the way you get closer yet is to add another 9. Can't add 9s on the other side. What makes it closer, remember this would be 3.0, would make it 3.01. So just insert a 0 to get closer on the right. There you go. And that's how I come up with my values for my table. Okay? They're not asking us to record our values from the table. They're just asking us at 3. Now, 3 is included in the top function x plus 6. So when I look at this graph, I actually want to, actually we'll do the table and then I'll do the graph. I included 3 in my table, but remember you don't include 3, okay? Are the values on the left equal to the values on the right? Are they getting closer to the same value? I'm going to say from the table, it looks like yes, they are both approaching 9. Now let's look graphically. Okay, graphically, for those of you continuing on to calculus, either next year at your high school or in college, piecewise functions only exist where they're defined. So let me do this. Whoops, too thick. Let's try this one in purple. So x plus 6 would be here. There's the y-intercept. So less than 3 would be here. Those are all the x values less than 3. And the 3 is included. What that means is the continuation of this graph is not. It is not defined on that part. Now let's do the other graph, 4x minus 3. Let me figure out how to change my color here. And let's do this, 4x minus 3. And it's only from 3 on. Now, technically, it would have an open circle and continue. And the rest of this graph would not exist. So what I'm asking is, on the right and on the left, are they approaching the same value? The answer is yes, 9. That's a recap of how to do it from a table and a graph. Piecewise functions, you have to know which portion of the graph is not applicable. Number 12, again, pause, open Desmos, create your tables. I'm not going to go over how to come up with the values. If you have issues, questions on the values, you could send me a direct message and then I'll hold a Zoom. I can personally Zoom with you and meet and help. I've done that a couple times last week. And then I'll hold a general Zoom for the whole class on Thursday. So we're looking at x equals 2. So again, I put 2 in the top function. Does it exist? Are we hitting the same values? Remember, the actual value at 2 is not so important. It's, are they approaching the same number? And the answers are no. They're not. On the left, we're approaching 7.4, and on the right, it's 1.4, 1.5. So the limit to meet does not exist. That's how you tell from a table. In the graph, when we look at 2, when I come from the right, now you might think, well, which way is the right? Or from the left. Come all the way from the left. And do you see 2 would be right around there. And then from the left, 2 would be right there. So not the same, does not exist, both from a table and a graph. 13, there's a video you could watch. X equals 2. We are going to try getting closer to 2 from the left and from the right, but we have to use the graph. So let's do the graph. So from the left, it goes up, looks like it keeps going up, and on the right goes up and looks like it keeps going up. They both go to infinity. That is unbounded, so the limit does not exist. Okay, it has to be an actual number. When they just keep increasing infinitely like that, the limit does not exist. And number 14, again, here is the table. They give us the values, so just pause it, type it, make sure you get it exactly right, and then they want 6 decimal places. So when I input to 6 decimal places, let's see, 1, 2, 3, 4, 5, 6. The 4 is not big enough to move it. Neither is that 4. Oh, none of these values are 5 or bigger, so we are just going to write in our answers. Let's see here. Oops, I'm going black. 998. Oops. Oops. I'm looking at the wrong problem. 3.894183. 3.998933. If MyMathLab says round to 6 decimal places and you do not, you put in all 7, it will count it incorrectly. Now I'm not there with you, so that could be very frustrating. You're doing everything right, but it's a rounding issue, so please make sure you read those rounding instructions. There we go. 3.998933. And then 3.894183. So that part can be a little tricky on MyMathLab if you are not careful. And then the limit as f of x approaches 0. Well, 0 would be right in here. Are we approaching the same value? Pause. What do you think? You can also look at the graph. The answer is yes. We're approaching 4 on both sides of the table and on both sides of the graph as we get close to 0. I hope this helped. Bye.